Hello. Today we're going to be looking at digital communications. So, before that, we need to know some concepts. So, the first concept is entropy. So, it's got to do with probability. So, you have a dice, or let's say a coin toss. So, we know that with a coin toss, the probability of getting a heads or tails is 0.5. So we can work out the entropy for that. So entropy, we write it as H and the probability. So we know the probability is 0.5. So the formula is P, that's for, let's say, heads, and it's log 1 over P1 plus P2 log 1 over P2. So the probability of P is 0.5, these two are the same, and the answer is 1. So the entropy of a coin toss is 1. So what does that mean? Well, it means that when you do a coin toss, you have no idea what you will get. You don't know if it will be a head or it will be a tails. The entropy is 1. That is like the highest. That's how you will be surprised. If it was 0, then that would mean you are not surprised. Maybe the coin, it has 2 heads on it. So if you do get a head, you're not going to be surprised. So HP, that would be 0. So you can do that for a dice as well. For a dice, the entropy, each probability for each outcome is the same. It's 1 over 6. So you would have like 1 over 6 log 6 plus 1 over 6 log 1 over 6 plus all of that, and then you add it together. So there's 6 of them. So that would just be 6 over 6. You're adding all them together. Log 6. And that is equal to 2.58. So that is the entropy for a dice. Because there's more outcomes, is higher, but that is the highest. And for each outcome, you don't know which is going to happen. So we can also find the entropy. So we found the entropy of a coin toss for a dice. We can also find it for the alphabet. So for the alphabet, we know it's A, B, C, D, E, F, G, H, I. And if you open a book, you will see that some letters, they occur more times than others. So you can work out the entropy for that. And we've done that for the dictionary. And so A, E, I, they have their HP. So the HP for A, E, I, that is equal to it's higher than 0.05. And the entropy for like HP for if you have B, F, G, that is lower than 0.02. So what does that mean? Why is the entropy for AEI higher than 0.5 and for BFG the entropy is lower than 0.2? So that means that you get more information if you get a B, F, or a G, and you don't get that much information because of AEI. So another definition of entropy is also how much information you get, and it links with probability. So AEI has a higher probability, so the probability is higher, so the entropy, it will be high. But the probability of a BFG is low, so the entropy is also high, it's also low. And this has to do with information, and we're doing this, learning about this because it's very much used. So the entropy of A, is it compared with the entropy of B, which one's bigger? Oh, sorry. So the entropy of HB is bigger. My bad. So this is not entropy actually. So this is like the probability. So the probability is high for A, BFG. I mean AEI is higher than 0.5, and the probability of BFG is lower, is 0.02. So if the probability is high, that means that the entropy will be lower, and if the probability is low, the entropy would be high, because it links with how much information we get. With B, we'll get more information about what the word will be. With A, we won't get that much information. Okay, so let's move on. So let's go back to the coin toss. So if the coin toss is 1, we are the most surprised, because here the probability, let's say, is 0.5, right? For a coin toss is 0.5. But if the probability, let's say for heads, right? Let's say it's for heads is 0.001. So basically, is you'll just get tails. Okay, for heads, right? So the entropy for this P is very low. Why? Because you know the outcome very easily, what is gonna happen. And if the head is like 0.1, okay, so you have 1/10 of a chance of getting heads, the entropy will be 0.47. Now we know before, if the entropy is 0.5, I mean the probability is 0.5, the entropy would be just 1. So you can graph that. And this is the graph. This is the graph. So for a coin toss, depending on the probability, if it's 0.5, you'll have the highest entropy and you'll be the most surprised. If it's a 1, you know 100% that you're going to get heads. the entropy would be very small. You can also do that for the dice, or let's do it for the alphabet, okay? So the entropy, we know that so the probability is between 1 to 0. I mean 1 to 0 to 1. So the letters like that have the lowest probability of occurring, let's say BFG, right? That's the lowest, like around here. Okay, and you have like BE, BF, BFG, and the one that like the most high, like AEI, they'll be here. So what we know that the entropy of these, we can graph it. So B, the entropy, how much information you get. If you get a B, it'll be very high. Okay, and for G as well. But for AEI, the entropy, you don't get that much information, so it's very low. So this is the graph. It's like this. The words that occur the most, they'll have the lowest entropy. The words that least occur, like Z, there's not that many words in the dictionary that start with Z, right? So if you know someone says, oh, the letter starts with Z, you can guess it out, like zoo, giraffe, no, I mean zebra. So there's not that many words, so you have more information if someone tells you Z. So this is how you graph it. So I hope you have understanding of entropy. So we're going to move on. It's still about entropy, but this concept is important. We'll be using it quite often, and it helps with digital communications, because depending on which letter you're sending, you can take advantage of that. So we know that HX, right? We'll just replace the P with the X. It's probability of X. So this is, let's just say it's binary, okay? X is could be 0 or 1, okay? Now probability of x0 log 1 over probability of x0 plus probability that x is 1, given that log is probability of x equals 1. Now let's say that x is the input, okay? And let's do the output as well. So let's say the output is also 0 or 1, okay? So we can work out hy. And that will be the same. I'm not going to write it down. So this is the input, this is the output. So if you somehow find out the output, can you work out the input? Well, this is what this means. So this is the formula. I'm just going to write it down, but I just told you, like, if you get a y, this is conditional. If you get a y, what's the entropy of getting, what's the entropy of x? So if you got a y, what's the entropy of x? So you can write that down. So that is the probability that y is 0, and then you have to write the entropy x given y is 0. These are just important formulas that you'll need to memorize, and the more you use them, the more you'll have the understanding. So right now you might not understand them, but it's good to know this. So this is the formula. It's similar to this, but we have more entropy. So this one, you break it down to this section and this section. So let's take this h of x. we can write it in terms of this bit. Okay, so just do it properly. So that is probability that x is 0 given that y is 0. So we can then do the log. So this is all log 2, okay? That's just letting you know. So log 2, 1 over probability that x is 0 given y is 0, and plus probability that x, so here we don't know what x is. X would be 1 or 2, but this is fixed, okay? So probability that x is 1 given y is 0 is fixed, okay? So that is log 2 of 1 over probability that x is 1. Now, so you can also, so we've done this bit, now we can also do that bit, but I'm not going to write it down. Okay, and then once you worked out this and you also worked out this, you can work out this one, okay? So these two are important to work this out. So probability, then you can just insert it there and you can work out h of x. So why is h of x important? Well, you can work out the mutual information between x and y. So mutual information, we write like this: x, and that is equal to h of x minus what we just worked out before. So this equation is important. This is the mutual information. So h of x is like how much information we have, and h of x given y, we subtract it from this. So if this is 0, we'll just be left with h of x. So what that means is that how do we get a 0 in the first place? Well, it's 0 because if you get, what's the probability of like having you get y and you get no information of x, or you get full information of x? So if you're given y, if your output is y and you know that output of y will be the same as the input. Sometimes they're not the same, but this time let's say is 0, because you're not that surprised. You know that when you get a y, that is the same as x, so you're not surprised. That's why it's 0. So it's all got to do with how surprised you are. So that's why it's 0. You're not that surprised. So if you do h of x minus 0, you're just left with h of x. So you didn't get any information. You're still left with h of x. So you want you're left with h of x. So you didn't get anything out of h of x. So that's why we will be using this equation, and I'll let you know more about it. So let's look at now the channels. Okay, so we'll be using all of these formulas. I hope you memorized them and wrote them down, because they're going to be a lot of questions that you'll be using them in. Okay, so now so for communications, you know that there's an input and then there's an output. So let's just say that x is the input. It could be a 0 or it could be a 1. Now, what is the output? Well, it could be a 0. That's the output, okay? Y. Or it could be a 1. So, simple, right? But that's not always the case. When you're communicating with someone, there might be some interference, and that interference will cause you a lot of problems. So if you're sending a 0 and there's an interference, you might get something that you don't know. Same with if you're sending a 1, you might get interference you don't know. So let's say when you send a 0 input, okay, and the output will be 0, let's say that probability is 1/4. So the opposite of that would be 1/4. So if you're sending 1 and you get a 1 in the output, that is a half, and then the opposite would be a half. So for this, this is a BEC channel, binary erasure channel. Okay, so for this channel, let's just do another channel. That's one channel. There's another one, BSC. So this one is very easy. You get a 0 and you're sending a 0 and you get a 0, which is good. You're sending a 1 and you get a 1 in your output, which is also good. But sometimes, for this channel, 1 and then you might end up getting a 0. You're sending a 0, you might end up with a 1. So that's an error, right? When you're sending a 0 and you get a 1, that's an error. So we say that's a F. That probability of you sending a 0 and you got a 1, that's F. And the opposite probability that you sending a 1 and then you get a 0. Now that would be obviously the opposite. If you do 1 minus F, 1 minus F. Now that's another channel. There's another channel which is called the Z channel. So it's important to know these channels, and we're going to be looking more in depth at them. So this channel, you're sending a 0 and you get a 0. That is the probability of that is 1 for this channel. So but you're sending a 1 and to get a 1, that's good, right? But if you're sending a 1, if you're sending a 1, you might get a 1 in your output, and if you're sending a 1, you might get a 0, but never 0 and then you get a 1, because if you think about it, if you send like no signal, nothing's gonna interfere, right? So you'll always get a 0. But if you send a 1, then if it goes through the channel, it might weaken, it'll be a 0. It might get stronger, it'll be a 1. So there's an error. So let's now apply the formulas. So let's work out h of x, the entropy of the input. So the entropy of the input, let's say probability of sending a 0 is sending a 0 is 2/3, and let's say the probability of 1 would be 1/3. Okay, that got rubbed out. Now probability of a 1, so probability of h, you just need to use that formula that we used before, and that is 0.9183. So That's the entropy of h of x. So this is important because remember the formula. Now we'll also need to work out h of y. So remember the formula, we want to work out the mutual information. Okay, and that is h of x minus h of x given y. Okay, so we need to work this out. So already we know that it's not half-half. You're sending a 0, 1. You have a more chance of sending a 0, which is 2 out of 3. So you won't be that surprised if you get a 0. So that's why the entropy is 0.9183. It's a bit lower. If it was 0.5, hx would be 1. Okay, so now h of x, how do you work out that out? Well, it's a probability y0, remember the formula, given h of x y is y0 plus probability that y is 1. Now h of x given y is y1 plus probability, remember this question mark for this channel, y is, we don't know, plus h of x given y is equal to y question mark. So we can work this out. First we need to work out this, then we need to work out this, and we need to work out this. But it's not that hard. So this, we can just write this as y is 0, and this is y is 1, and y is question mark. This is very easy to work out because if y is 0, this is the y is 0, right? And you'll be 0 surprised that it's a 0, right? Because from 0 there is only 1, and that's this 0. So that is, let's just say that's a, that is equal to 0, because you're not surprised at all when you get a 0 as your output, and you'll know 100% that input will be a 0. It's same with this. The entropy that you get a y is 1. What is the x? How surprised are you? Well, when it's 1, you know 100% that the input would be another 1. So that will not surprise you. But for this one is a bit different. Let's say that's C. You get a question mark. And you don't know if it's a 0 or a 1. So you will be surprised for either one of them. And you'll just have to use the previous formula that we used. And remember, h of x given y is question mark. Well, remember, it was the probability that so you can always, once you've written them, that's why it's the benefit of writing them down. So probability that y probability that x is 0 given that y is question mark, that's fixed. H is you need to go for the logs now. Log 1 over probability that x is 0 given y is question mark plus probability that x is 1 given that y is question mark and then log opposite of that. So once you work that out, then you can put it into this equation, and probability of getting a y question mark is 1 out of 3. Okay, so we already know the probabilities of 0 for, this is for the x, this is for the y's. We already know that. Probability of 1, probability of question mark. And yeah, so once you work that out, then you can put it back into this equation, and then you can work out ix. And you can do the same for this formula as well. We're not going to do that now, but so now I hope you understood, you got familiar with these channels. So now we're going to do source encoding. So why did we learn that before? Well, it's important that we know, like, when we are trying to send information, we will go through a channel, and we need to know, like, the ways to improve that channel. So let's look at source encoder. So when information goes through, first it needs to be turned into bits. So that's the job of the source encoder. Source encoder. So entropy will be using that in this topic as well. Source encoder. So if you have some amount of information, you can write that into bits. So how many bits you use is very important. We want to use the least. So if you have 8, okay, if you have 8 symbols, you want to encode it. Would you use 1 bit, so like a 0 bit or a 1 bit? How many information can you store in that? You can only store 2. So 0, let's say that's 1 symbol, and 1 is another symbol. You can have more bits, so this is 1 bit. You can have 2 bits, so you have a 0 0 0 1 1 0 and then 1 1. How many bits can you store? You can only store 4 bits. 4 symbols. So you need more bits. So, and if you want to work out for 8 symbols how many bits you use, well, you can use the equation log 2, put the number of symbols 8, and you get 3. 3 is the number of bits that you will be required to store this information. And this is a compression. Okay, the symbol might be big, you're compressing it down into bits, and you're using 3 bits. So this is called lossless encoding. Lossless, you're not losing any bits. So we're going to want to save those bits, but you don't want to use 3 bits, because there are many reasons why we won't just, for the amount of symbols we have, we won't just use the number of bits, because that increases a lot. 16 symbols, let's say there's 16 symbols. How many bits? Well, log 2 16. What is that? That's 4 bits, and that would keep on increasing, more bits, so only 16. So to save the bits, we need minimum compression, and that's where entropy will come in, and we will be learning that after the next episode. Thank you for listening.